ready to get the meeting started with our first presenter, Andy Beaton, and the sky this month.
Am I on? Excellent. Hi, my name is Andy Beaton. I'm speaking to you from my office in the basement at home here in downtown Toronto. And this is my first experience doing the talk out into the void of the internet, and it's kind of spooky. I'm just looking at this blank screen here and not knowing who's out there listening. So I hope we get through this okay. Before I start, I want to say thank you to Dennis Gray. There was a bit of confusion. Dennis did a bunch of preparation for the same talk that I'm doing, and very kindly passed over a bunch of notes and useful stuff that I've included into my talk. If you see anything really good, really clever, it's almost certainly Dennis's stuff, so say thank you when you see him. So tonight, we've got the big picture, key dates, we've got the moon, the planets, stuff in the deep sky, double star in deference to Blake, who loves his double stars and has got me hooked on them too, variable star, and a few highlights of the space flight scene in the next few weeks. So starting with the big picture, looking to the west around sunset tonight, assuming that you weren't looking at the same clouds I am when I look out my window here, what we see is our late winter and spring constellations sinking away. Only one planet of real interest right now, and that's Mars. I don't think there's much to see around Mars right now. It's pretty far away and getting pretty close to the sun. When we get closer to the next meeting, which I believe is June 2nd, and look at the morning sky, there we see some action. We can see the moon will be up, but we've got a whole parade of planets, starting with Pluto. I'm giving it planet status for this anyway. Saturn, Jupiter, and Neptune. Uranus comes up a little bit later, but it won't really be visible. At the same time, we're going to have all our big summer constellations, and by dawn in June, we'll even be starting to see the fall constellations. The nights are getting longer. This is we're the people who are most upset about this. We're getting less and less observing time as we get closer to the summer solstice. Tonight, Astronomical Twilight ends at 10 after 10. That's local daylight time, and starts again at 3:45 in the morning. So you've got 5.5 hours of proper observing time. By the time we get to June, then we're looking at well past 11 before it gets reasonably dark, and almost 3 o'clock when it starts lightening up again. So if you've got your deep sky photography projects lined up, you're going to have to spread them out over a few nights. So important dates. The new moon is on May 11th. That's the big one. Moon is at apogee on May 11th and perigee on May 26th. Apogee is close. No, perigee is close. Apogee is far. If you have a camera on your telescope, it's probably worth taking pictures of the moon at these two dates and comparing the angular size of them. It's interesting to see how the moon grows and shrinks as it approaches and disappears. Full moon is on May 26th, and it is a supermoon, and it's more than a supermoon. It's a total super dragon blood moon lunar eclipse. It's the whole ball of wax all at once. I don't really love these supermarket tabloid descriptors of lunar activity, but I can assure you that people who are not deeply into astronomy pick them up, and they're going to ask you about them. So I'd like to, at least be aware that these things are happening. We have the Eta Aquarid meteor shower, and it peaks tonight, tomorrow morning. So if you are under clear skies, then I would advise you to go out and have a look. Um, it's not quite a Perseid quality shower, but it's a good one. There's going to be a few dozen per hour, so get out if you can. And on May 12th, if you're in New Zealand, you'll get to see Venus occulted by the moon. Normally, I wouldn't bother telling people this, but because nobody in Toronto is going to see it. But since we're out on the internet, I have no idea who's going to be listening to the conversation over the next month. So, maybe someone from New Zealand is going to pick that up and see the occultation, and my effort will not be in vain. So we've got the moon coming up. First quarter on the 19th, full moon on the 26th, last quarter on June 2nd, the day of the next meeting, and May 11th is our new moon. Now, for people who are keen on trying to find the lunar X, that's a feature of the moon where you get light coming from a certain angle, lighting up the rims of two craters. It makes it look like an X. You can Google it at your leisure and see exactly what it's supposed to look like. But May 18th, starting around 7:41 Eastern Daylight Time, I've done this Toronto time. If you're looking from another time zone, you can probably do the conversion yourself. But that's when that is. May 26th is our total lunar eclipse. Best viewed from the South Pacific. If you're watching from Toronto, it'll be setting around 5:30 in the morning, depending on your horizon. If you're in Toronto, you probably won't even have a horizon. The moon will barely be entering the umbra at that point. And as I mentioned before, people are going to be hyping up the supermoon. A supermoon and a total eclipse together, that's got to be good for attention from people who really don't know anything about astronomy. And if your relatives are like mine, you're going to get all kinds of requests for information. What's a supermoon? What's a blood moon? And this is your chance to spread some science around, spread some useful information, tell them how things work, tell them that the Earth isn't flat, and that's why the shadow of the moon is round. Full details are on timeanddate.com, and I believe they'll be live streaming the eclipse as well. And I imagine as we get closer to that date, more websites will crop up with a live stream as well. So we get our usual planets. Mercury will be slowly appearing in the evening over the next month, and then it'll pop up as high as it goes, then pop back down and fade as we get closer to June. Venus is slowly rising in the evening sky, and the longer it goes, the brighter it's going to get, the more obvious it's going to get. By summer, it's going to be insanely bright, and no one will be able to miss it. But it might be an interesting project to see how early in the cycle you can see it. Mars is disappearing into the evening twilight. It's tiny. It's low to the horizon. It's going to be washed out by twilight. I'm not sure I would even bother looking for it at this point. I mean, interesting to see it, but you're not going to see anything like ice caps or rovers or anything fun. The big planets, Saturn and Jupiter, they will be rising in the morning sky. Saturn first and Jupiter after. They're both at pretty low declinations down in the Sagittarius area, or the one beyond it, Capricorn. They'll be at low declinations, so you're not going to be able to see an awful lot of good visual detail, but you're definitely going to see moons and rings and all the stuff that that people like to see when they look at Jupiter and Saturn in the telescope. Now, this is something that I got from Dennis, and I'm grateful to him. Mutual occultations. It turns out that the Earth is crossing the orbital plane of Jupiter's satellites between March, and November. Happens every 6 years. And what's going to happen is we're going to get events where the moons of Jupiter are eclipsing each other. And I've got to admit, I've been looking at Jupiter for years, and I've never seen one of these, so it's a thing to watch for. There's a website here. I believe the talk is going to be posted online at some point, so you can scoop it up at your leisure. Otherwise, I'll get it posted somewhere on one of the RASC websites. But it has a list of the events. The ones that are worth watching for this month, May 11th, Europa is eclipsing Ganymede. May 20th, Io is eclipsing Europa. And May 25th, Io is eclipsing Europa again. Yeah, this is a cool thing. I've never seen anything like this before, so I'm going to have to watch for it. Clear skies permitting. Uranus and Neptune. Uranus is too close to the sun this month. We're not going to see it. Neptune, if you're up early in the morning before late May, early June, then you should be able to see it. With a reasonable sized telescope, you should be able to see not only Neptune, but its largest moon, Triton. It's a bit of a challenge. It's a 14th magnitude or so, but I'm pretty sure many of the people watching here have a telescope powerful enough to look for something like that. On the whole, not a great time for the ice giants. They're fairly low to the horizon, even at their best. But yeah, they're there, and if you're in the mood to look for giant planets, there you go. Pluto and Ceres, we can quibble about whether they're planets or not. I don't think they are, but I'll call them planets for the presentation. Pluto's in Sagittarius and is finally getting away from the Milky Way, so it should be findable. It's about 14th magnitude right now. 10-inch or larger scope ought to be able to find it. The best way, as always, is to take a picture and then take a picture a few days later and look for it moving, because even if it is visually findable, it's going to be tricky to see with to distinguish it from the background stars. Ceres this month, too close to the sun to observe, so I think we're going to have to give that one a miss. So I like to throw in a bit of deep sky stuff all the time. M51 with the Whirlpool Galaxy is the one I thought of this time. And there it is. Everyone's seen the picture of it before. It's an excellent target for this time of year because it is so bright. It's a face-on spiral galaxy. If you can get out of the city under good skies, you can see spiral structure with an 8-inch or larger scope. 6-inch, you can see the spiral arms, but it's kind of hard to figure out what they are or how they're connected. Just about any telescope would also pick up the companion galaxy. So you're seeing two interacting galaxies at once, which is always a fun one for the bucket list. And our picture. Now, if you're a more experienced observer and you've seen M51, you finished your Messier list, there's still stuff to look for. Looking for the bridge of matter connecting the two. It is visible to invisible light, needs a large telescope and a good dark sky, but it can be done. Looking for the H2 regions in the galactic disk. That's all these red splotches all over the place. It can be done with a large telescope. If I were to try it, I would try it with a filter and a camera and try and get a picture of them. It's a challenging thing with the human eye, but because they're that beautiful hydrogen red, it's easy to filter out. In fact, if you have a filter, you can probably do it in the city as well, because there's not a lot of hydrogen emitters in downtown Toronto. M51 is also the source of a lot of way more supernovas than we would expect. We've had them in 1997, 2005, and 2011. I don't know whether it's just a weird coincidence or whether there's something about this galaxy and its interactions that make it a supernova hotspot, but it's probably a good place to try visual supernova hunting. It's a thing that can still be done. Some people are still doing it. And it's close enough that a supernova should be visible to a modest 8 to 10 inch sized telescope. So we have comets and meteors. The Eta Aquarids peaking tonight, but continuing on until May 28th. Obviously, we're not going to be the peak number of meteors, but we should still be able to see some. Smaller meteor showers or meteor dribbles, the Eta Lyrids, the Tau Herculids, and the daytime Arietids throughout the month. I wouldn't go out to look for them, but if you are out and you see a meteor, you can see if it traces back to one of these vectors and try and figure out if it's a part of a known shower or just a sporadic meteor. The daytime Arietids, that might be a tricky one because obviously it's daytime, but if you're interested in the project of setting up a radio receiver, tuning it to dead air, and if a meteor comes over, the ionization will reflect a radio station from well out of your normal range. You'll get a sudden burst of voice or music. That's a project worth doing, and it's especially good in that it can be done in daylight. It can be done in rain. You can do it any time that you can't do regular astronomy. So we got some comets. C2020 R4 Atlas is the big one right now. 9th magnitude in Corona Borealis. And Dennis was kind enough to cook up this little map for me. It's not too far away from M51 now that I think about it. Just south of Canes Venatici. But it's moving fairly quickly and it's fairly bright, so it's going to be the comet to see. I would say it's a good time to either track it down by the internet or any astronomy software, because it's going to be in a different place every night, and I don't think I can really show you how it's going to be whenever it turns out to be clear where you are. We've got 10P Temple 2 in Pisces, C2020 T2 Palomar in Canes Venatici, and C2019 L3 Atlas in Perseus, all of them brighter than 12th magnitude, which makes them visible to a reasonable telescope, skies permitting. There's a map again. So I've picked a pretty bright and obvious double star this time. Blake likes to go for the obscure ones, but I'm hitting for the people who have not got a lot of observing experience here. Also known as Cor Caroli in Canes Venatici. The Observer's Handbook gives it 3 exclamation marks for its amazing beauty, and it really does look great when you see it in telescope. One is definitely blue, one is a good deal whitish. They call it green, but it always looks white to me. People who have talked to me about astronomy before know that variable stars are my own particular obsession. And one of the reasons I did pick Alpha Canis Venatici is that it is slightly variable. It's an interesting one in that it suffers from many giant sunspots from strong magnetic fields, which leads it to vary in brightness about 1/10 of a magnitude every 5 days or so. It's a tough one to measure with the naked eye, but if you've got a photometer on your telescope, you could probably go out and measure it. And if you don't want to go out and measure it, you can just go out and enjoy a staggeringly beautiful double star. So since I've told you about a variable star under the guise of double stars, I've gone for a not a variable star under the variable star heading. What I've picked this time is 3C273, a quasar in Virgo, a galaxy undergoing an explosive event at its core, and it's been going on for a long time. It's about 2.4 billion light years away, and it is the farthest thing I have ever seen with my eyeball. It's about 12 and a half magnitude. It's got a 6-inch or larger telescope and dark skies. You should be able to see it, and it looks very much like a star. It is powered by tons of material spiraling around the supermassive black hole at its center. And as it as material spirals in, it blasts off tons of radiation, which is what we're seeing in the form of light, and massive jets blasting off into space as well, which I don't think any of us could see, but it can be done with a large telescope and a long period camera. Now, the cool thing about it is because it's a black hole, it's a very compact object, it can change its characteristics very fast, which makes it suitable for amateur observation. A lot of variable star observing has been made slightly obsolete by all-sky camera surveys. You know, they'll take a picture tonight and they'll take a picture next week. And your long-term variable stars will be carefully measured automatically. But when you're looking at a quasar, it will change very rapidly, you know, over the course of hours, much faster than the sky surveys can keep up with. So it's actually a really good target for us amateur data collectors. As usual, aavso.org is the place to go for finder charts and more information on how to observe. I strongly suggest everybody give observing variable stars a try, because it is fun it's fun to be able to contribute actual data to science. So coming up in spaceflight highlights, I mean, the big one has got to be Perseverance and Ingenuity on Mars. I think everybody is looking forward to seeing helicopters flying around Mars, taking amazing shots and views that we have never imagined until now. India and China are both launching space missions over the next few weeks. The exact date was still to be determined when I put this together. Tianwen-1 is projected to land on Mars sometime within the next month. That will be worth watching for. I don't think we'll get quite the same coverage as we did when Perseverance was on its way down, but we've got to watch for it anyway. ISS passes late at night, early in the morning, just about every night until the next meeting. Dennis has picked out a particular favorite, May 24th at 1:40 a.m. The ISS is potentially going to pass between us and the moon, if you're viewing from the Mississauga area and the orbit hasn't been altered. I haven't seen a lunar transit myself, but I have seen pictures that people have taken with the space station silhouetted against the moon, and it's pretty spectacular. And heavensabove.com is your best place to go for up-to-date information on when and where the ISS and other space missions are likely to be. And once again, what if it's cloudy, which it very often is? I will suggest visiting zooniverse.org, where they have a heap of citizen science projects, which mostly involve taking data that's been collected by telescopes and observatories throughout the past few years and putting human eyes on it. Turns out that humans are much better than machines at picking out the anomalies that these scientists are interested in. So we have a dark energy explorer examining distant galaxies, looking for evidence of dark energy and expanding universe. Disk Detective is searching for planetary disks or protoplanetary disks around other stars. Burst from Space is working on looking for matches between radio bursts and visual objects. And Radio Galaxy Zoo is a project where they're getting people like us to classify galaxies by their radio signatures. All stuff that anybody with an interest in science can get involved in. You just click on the link and everything gets spoon-fed to you. So it's a good way to get involved. And that is what I have for this month. Thanks for your time, and I hope we all have some clear skies.
Andy, thank you very much for your presentation. Great content, great delivery. We're going to have you back.
All right.
So
now that I know my computer works, I can do it.
I'll be in touch. So let's go to the internet. Let's see if there are any questions for Andy.
We do. We have one question coming in from Blake. How do you measure variable stars, and do you use a photometer?
There are a couple of ways to measure variable stars. You can use a photometer and carefully measure the amount of light you're getting, but the way I do it is through visual means. I've downloaded charts from the AAVSO, and it has the star that I'm interested in and neighboring stars of known brightness. So I will take a look at my target star, compare it to the this 11th magnitude star over here, this 12th magnitude star over here. It's about 3/4 of the way between the two towards the dim end. So I'd say it's probably about 11.7. And as it turns out, human eyes are remarkably adept at that kind of interpolation. They, 1/10 of a magnitude estimates are commonplace. Some people can even do better.
Thanks. Which scopes do you use for the variable stars?
What I use is an 8-inch Schmidt-Cassegrain right behind me here. I use that, and the widest eyepiece I have, it's a 30mm Plössl to get the widest possible field of view. If I'm looking for something down near the limits of the telescope's ability to grasp, then I will use a higher magnification eyepiece and get a closer look. As it turns out, the dimmer the star, the more variable stars in the same range are going to be available for comparison.
Bruce wants to know what's in the stars for the Leafs.
Having following the Leafs since 1967, I predict an outstanding playoffs until they choke in the semifinals. That's the Toronto way.
That's all the questions. Thank you.
Okay, thank you.
I'll just throw in a comment in regards how to measure variable stars. Some time ago, Dennis Gray delivered a presentation to us about using a DSLR camera for measuring variable stars. There's some freeware applications out there that can be coupled with a camera, digital camera, and they can output the magnitude of the star. So that's something you can search on the internet for if you have a DSLR already. And of course, CCD cameras as well can be used. All right, so thanks again, Andy.